Thomas is from Renault Sport, and he's on the Renault Sport Formula One team. Welcome, Thomas.
Thanks, Greg.
All right.
Hi, Mr. Clicker. Thanks for the clicker. Hi to everybody. So the next half hour, I would like to give you a short view on how data is driving an industry like us, which is known for being excessive in money, but also very, very fast, not only in product, but also in changing processes. So I will start with giving you an overview about Formula One, the industry we are competing in, and for this I need the people to dim the light. So it's all about emotion if we speak about motorsport and racing. So to get a little bit of this feel, I have a short video. So for this, we need to dim. And it's normal, it's black at the beginning, so it's not a failure. You just need to feel and listen and watch. Okay?
All right, just try to be smooth out there, try to stay relaxed.
Pace car going behind the pit wall. Green flag comes out right now.
Hold a brake there, hold a brake, hold a brake. Things are just undrivable.
Door to door for the race lead. Side by side, they come up. Turn number 3.
Pull the clutch back in. Pull the clutch back in. Pit this lap. Pit this lap.
Welcome to my world of Formula One. But Formula One is not only a racing series. In fact, it's quite a big advertising business. It's a marketing platform. It's a global platform which has a 2 billion turnover on an annual base. It's a very global sport. It's acting every second week throughout the year. So we are reaching a lot of people. It also attracts a lot of well-known, very prestigious brands. So this sport was built in attracting all the top brands of the world, and you will see some of them are listed there. And it is something which is very attractive for people. It's not so well known in the US, I know, and I will show in the next slide how the demographics of our audience is related. But it's a business which is still growing, which we try to promote around the globe. And if you look to the audience itself, we are still reaching 2 billion people each race, which is quite a lot. We have 750 million live viewers every race we are doing. And we do 21 races this year, every second week during the season, which starts in March and ends in November. And you can see how it's distributed. And we are really a global industry in terms of reach. There are more than 240 companies involved. And if you take all the revenue of all these 240 companies together, we have a staggering 5 trillion annual revenue base. So it's quite a small club, but quite a powerful club. Now I want to speak about ourselves. So you see, it's a marketing platform. It's a global industry where we are competing in. But who are we? So who is Renault Sport Formula One team? And for this, I show you again a short video. It shows you all the drivers ever driven for the team since the start in '81 up to now. So if somebody is interested in Formula One, he should count the world champions, the names of the world champions. I will ask you afterwards and see if somebody is able to tell me how many world champions were ever driving.
Birds flying high, you know how I feel. Sun in the sky, you know how I feel. Breeze drifting on by, you know how I feel. It's a new dawn, it's a new day, it's a feeling good.
Anybody counting how many world champions? Yes? 7, absolutely correct, yeah. We're very proud of having 7 world champions driven for the team. We were just having a change of ownership in January, so we were bought by Renault again. This is our current lineup of the drivers, Kevin Magnussen and Jolyon Palmer. If you look now to this slide, so we were founded in '81 by Mr. Tolman, where Ayrton Senna was driving for us. Then we had a very prosperous time in '86 to 2001 under the Benetton family, when the Benetton family acquired the team, with young Michael Schumacher winning twice the driver championship. Then the team was sold again to Renault, Renault as we are today, as Renault Formula One team, and it again enjoyed 4 titles with Fernando Alonso, winning 2 titles, the only titles he ever won, by the way. And then in 2010, the team was sold to a private investor, a company in Luxembourg, and it was running under the name of Lotus Formula One team. And just as I said before, since January we are back to Renault again, which bought again the team, and we are running this year as Renault Sport Formula One team. But what in fact is always said about us in terms of the DNA of the team is we were always a team which was known not to outspend the competition in terms of money, because that's something easily you can do in this industry if you have a lot of money, but we were always known to be outthinking the competition, trying to do it a different way, trying to innovate, because innovation is all about what counts at the end of the day in our industry. If we come now to the product itself, the racing car which we produce and with which we are racing, and we are calling it a data-driven performance machine. A Formula One car is the most tested car at the moment in the world. It's the most powerful car in terms of weight to horsepower ratio. It pulls more than 5G to a curve. Why is data so important? Because if you think about the 70s, we also had Formula One cars. They were also very performant and very fast. And we had no data, no sensors on the car, and we were still to innovate every year a faster car. So I'm going to explain you a little bit why IT and technology and data was changing this, and now we will not be able to compete anymore today in a championship without having data and IT in our back. So what do we need? So we always start with a CFD model, that is the aerodynamic shape of the car. And for this, we need a supercomputer. We have a 38 teraflop machine standing in Enstone, hardware standing physically there. Just as a reference, you need something like 32 teraflop to calculate a nuclear explosion. It's quite a powerful machine in terms of what it's capable of doing. We run, or we produce something like 100 gigabytes of data per hour on these machines, and we run it 24/7. We run 500 different models of aero shapes every week through this machine. It takes us normally something like 6 hours to calculate a model, a shape of the car. So we schedule all these models in a way that when people go home and they're coming back in the morning, they have the results visually there. Then after this, we go into a wind tunnel, and we have a 3,000 horsepower wind turbine in there, which is producing 50 meters per second airflow for a 60% scale model, where we are testing the different parts and the different configurations. We are testing something like 600 different parts at configuration every week, again, in terms of the aerodynamic shape. We run normally 30 minutes in the tunnel, and normally we are able to predict after 3 minutes of a run if you're going to achieve the predicted targets in terms of performance or not. If we don't see it, we abort after 3 minutes, not to waste 27 minutes of valuable time of running in the tunnel, because this is regulated and we need to report. So every minute in a tunnel is very valuable time. So if we can see after 3 minutes we are not going to achieve what we think we're going to achieve, we abort. A car consists out of something like 15,000 different drawings, and it's built out of something like 4,000 assemblies or parts where the engine is one part. So it just gives you as a reference in terms of what we are producing. if we speak about agility, speed, accuracy, yes, that all defines our product. But it's not only the product itself, and that's the wind tunnel and the model which we are using in the tunnel to do so. It's also about business processes which need to support this. And a very good example I always use is when we started to get into the wind tunnel and having this high rate of different models going through this, we were not able to produce anymore with conventional manufacturing technology the parts we needed for this model because we changed so often every half an hour. You can imagine. So 14 years ago, we started to 3D print. So long before it was known, and we have a very long-standing partnership with a technical partner of a 3D machine producer. And that's where the business process was driving the technology, and not the technology was driving the business process. So just as a slight insight. If you look at the product itself and the car, obviously it's a highly equipped car in terms of sensors. We are running, all these dots are the different sensors. We're running more than 200 sensors on the car. We are able to run 2,000 sensors on the car, but for weight, during a race, we only run 200. What we are doing with these 200 sensors, we are generating roughly 2,000 statistics about the different parts of the car. This is a good example. This is about the engine, where we monitor the different levels of performance of the different sections of the car, where we have thresholds of limits. When they go above it, we trigger an alert. We need then to see if the sensor is faulty, and we don't have a wrong reading of the sensor or not. We have all these sanity checks we are running. And we're running this all at the speed of something like 2,000 hertz. That means 2,000 times per second we are data sampling and giving this data back. This is all a live transmission coming from the car in terms of telemetry. So whenever the car is coming through the start-finish line, the beacon sends the data to the pit wall, and that's where we are receiving the data. We are using technologies like stream analytics, as Greg said, where we're sitting on the data and analyzing fast, because obviously we are in the business of making fast decisions. So we have not the luxury to buffer the data and then to run the analytics over it, so we're sitting on the data stream. What we're also doing is we are duplicating the data and sending them back to Enstone, to home, because we are limited in terms of personnel going to the race. We can take something like 100 people to the race, or something like 500 overall, but that is not sufficient to do all the analytics at the track site. So we are sending all the data back and running the data there as well and feedbacking again back to the track to make the right decision. Now about data and data-driving transformation. For us, it's very, very clear that data is driving transformation. We are transforming all the time, from race to race. None of the cars from one race to the other is the same car as it was before. Because the track is different, obviously, but also because of the innovation we can generate between track and track. To give you a good feel, we can make a car roughly 2 seconds faster between the beginning of the season and the end of the season. And our business is really in the tenths of a second. So it's a huge step in terms of performance increase during a season in what we are doing. So we're collecting with the data, with the sensors, the data. That obviously delivers us insights about the performance of the car, but gives us also hints in terms of how to improve. This leads to proposed changes, and that changes can be product-wise, but also be process-wise. That means we go back to lap, and if I say we go back to lap, that's the 2 weeks window we have between the races. Then we are going to change manufacturing processes if needed, and then we're going to repeat this. If you think this now at the race, we do this then more or less each lap. We obviously don't change the product in terms of the racing car, but we are changing obviously the strategy how we use the product. The pit wall always makes decision, you know, if we push during the race and try to overtake, or we cruise. Especially now we have hybrid engines. We have this famous saying of cruising behind, where you lift the throttle to recover energy, because it's a hybrid engine where you recover energy. And so we run through this cycle lap by lap, but race by race as well. And after each race, we obviously go into a cycle of innovation and new products. There's a lot of speaking about how can we, being such a special industry, be an example for the real industry, I call it. But if you think a little bit about it, it's not so different, in fact. We are exactly like a normal producer. I normally use a mobile company who produces mobile phones. It's all about going to the market and being speedy in the market. You need to bring every 6 months a new model for a mobile phone, otherwise you're out of the market because the customer is going to buy something else. And we are exactly in the same. Our cycle is only 2 weeks. And that's where we speak about IoT. So we were speaking already, about the sensor side, how we're going to acquire data. So obviously our product delivers a lot of sensor, but also the factory delivers a lot of sensor in terms of the machine we are using. All of our, CNC machining centers, our carbon production line is connected to the network, and the sensors all deliver different stuff. We said we collect. Obviously, we produce an enormous amount of data. I can tell you just the data we are collecting on a tire, which we are using now for a machine learning exercise, is 2 petabytes of data just for the tires for the last few years, where we're collecting data on the tire. We're speaking about the transformation which is initiated after getting the data. And now we are at the stage, since 2 years, we are at this stage where we predict, where we start to apply machine learning algorithms to help us gathering insights. And that's where we, in fact, train our algorithm to detect, because the amount of data we are producing, human beings are not anymore able to, to see the patterns. It's simply too much of data. It's data overflow or overkill for a human to be able. So we're using all of this modern technology now to find the insights, and we are doing this all cloud-based. So we are running this all in the cloud. We are even on this part here, we are collecting the data. We are moving with our ERP system also to the cloud in terms of having all this data available to be able to run all this data in a fashion that we are able to do so. But how do we produce this? This is all about the industry. How do we produce stuff like this, and what is involved in getting this? If I would have to characterize the business, we are in fact a prototype manufacturing company, which is producing 2 different cars every 2 weeks, so something like 100 products on a yearly basis. Our lot sizes are between 2 and 5 parts. That's what we are producing. And another short video for you to see the factory. This is a very speaking picture for me. It may look for you like chaos, but it's in fact a pit stop. So for the people who watch Formula 1, when we do a pit stop at the race, it takes roughly 2 seconds to do a pit stop. Even though it looks like chaos, all of the pit stop equipment is monitored by video. So we do a lot of motion studies about how people move their arms and their hands to be able to do so. All of the equipment used in terms of the wheel gun, the lifting jigs, etc., are prepped with sensors, so we know exactly how long the guy pressed the button, what kind of pressure at the wheel gun was, the torque which the wheel gun delivered. All of this is measured. And only due to this, we were able to reduce this time to 2.5 seconds. I think you will see the next few years something like coming below 2 seconds to do a pit stop. But I think we are reaching the physical limits of the human body of being able to do stuff like this. But it's a very good analogy for the business processes as well. So the pit stop crew, in fact, trains 4,500 times per year a pit stop, which they need. So they perform every day a few times a pit stop, just for the repeatability, for knowing this. It's almost like army drill, yeah, for them in terms of doing this. But the same applies, in fact, also to our business processes. We seem to be very flexible, but in fact, we are very strict in terms of how we run the business. We change very often the business processes, that's correct, but we are very strict in terms of adhering to the business processes. If you look now at the factory, so this is the complete factory. We are located in Enstone in the UK, close to Oxford. It's very interesting that all the major Formula One teams are within 30 miles radius to each other, so it's a real cluster of racing technology you only find in the UK. It's a British racing series, so we are roughly 500 people. I have to go one back. I think it already scrolled. So obviously the car is designed in CFD, computational fluid dynamics, which is the aero shape, which is located here on the top floor of the wind tunnel. The wind tunnel building itself and the simulation. So this is a new building we just built recently where it hosts a simulator. I will speak later about this. Then advanced digital manufacturing, which is 3D printing, which we put very close into the wind tunnel next to the tunnel itself to reduce the lead times. Then the car is 85 to 90% carbon, so we have a very, very big carbon shop where we build all the parts ourselves. So we try to build everything ourselves. We have a very big R&D department because before we are allowed to put anything onto the car, it needs to qualify through 4 steps of approval. So it needs to be design approved, it needs to be production approved, it needs to be R&D approved, and it needs to be race approved. Only then we are allowed to put a part onto the car, because it's very, in terms of safety, very important, because we can easily kill somebody if it's not safe. And for this we have quite big labs where we do all the destructive testing for the parts, and the non-destructive as well. Then, obviously, electronic has quite a big influence. And if you speak electronics, then we speak about the electronic sensors, but also the software we're running on the car. And we are going really to an extreme in terms we're producing most of the sensors ourselves, in-house, as well as we are designing all the PCBs for the boards for the electronic ourselves, and then we assemble them ourselves. So we really try to control the complete production process from A to Z. And we're using, again, a lot of simulation tools. We have a D-Space simulator where we run all the softwares before we put it onto the car, not to have any hiccup during a race. And now the latest, the driver in the loop simulator, which is a simulator which is very similar to what you're used to if you go to an aerospace company where they have these big rigged simulators where the pilots learn to fly. In fact, it's used for this as well, in terms for the young drivers and the new drivers to learn the tracks. But the real benefit of a simulator is a different one, which I would like to explain you. In this, when I speak about the new design approach, the classical design approach, everybody knows, you design, you produce, you test, we say race, but you put it into the market, you get feedback from the market, and then you go back to the design board, and it's a iterative cycle like this, yeah? And we have all the classical, departments we use for this, of doing so. But why is the simulator allowing us now to do it a different way? Because we have all the data, we were able to construct a virtual car, a data model of the car, to an extent where every single screw of the car is modeled mathematically, and we plug this into a system, we can run this, and when the driver comes to the simulator, he feels like being in the real car. To an extent that we recorded all the engine sounds, so when he sits there, he gets the sound of the engine, the real sound of the engine into his earphones, in terms of having the force feedback on the steering wheel or on the pedal, exactly identical. The only thing we cannot quite simulate are the G-forces. We can maybe simulate something like 1.5 G. It's in fact a question of the platform, the size of the platform, to get the acceleration. But we play a little bit with his visual perception in the eye, and he feels a little bit more acceleration. And the funny thing is, not every driver is in fact able to go in a simulator. A lot of people get motion sick. So a very famous example was Michael Schumacher. So he got sick after 2 laps and he needed to get out of the simulator. So even though it's a very nice tool, it doesn't work always with each driver. So, but why can we now have a different design approach? So in the past, we were producing a part, putting it on a car, put the driver in, and go to a test track and test it. Now we do exactly the same, but the reverse. So we have our simulator, and we change some of the parameters of the model where we think we can gain performance. Put the driver in there, let him race, put another driver in there, let him race as well, and if they're all consistently better, then we go back to the design board and tell the engineers, look, now you need to design a part which has exactly these mathematical characteristics or physical characteristics, and then we can save, in fact, 1 loop of putting parts to a track and do the try and error. And this has saved us a lot of money and a lot of time, especially. It saves you a lot of time. And in our industry, it's all about saving the time in terms of iteration. Each time we do an iteration cycle in terms of engineering, we gain performance. Each time, because our engineers are very creative and they find each cycle. So the more we can iterate, the more performance we get. And this is a very good example of showing that data doing it virtually, in fact, can deliver this kind of benefit. But we have also something else, we also call it the development race. It's not only the race at the track, it's also the development race we have, in fact, against the other teams, because, in fact, it's all about being faster than the competitor, not absolute performance. For this, we have this kind of, and this is our race calendar, every 2 weeks, a different race. As I said, this year we race in 21 different locations, and we need to, we can be in Japan and then in Brazil. So it's quite stressful. It's quite stressful on the body for the people who need to travel and the drivers itself to go from, continent to continent every 2 weeks. I already spoke about the 1,500 drawings we're going to produce. But what is more important for me is almost twice the amount of updates we're running. So it can easily be, and I told you we have very small lot sizes, up to 5, 6. That when we start producing, the first part is not the same version as the last part of the 6. And that is, in fact, our challenge to manage all of these rapid changes. We write the software ourselves, but it's race-related. It's all .NET software we are writing. And we're releasing more or less every day a new release of software. So that gives you, again, kind of an insight how quickly we need to react and how fast we react. For us, in terms of input parameters, yes, we need to understand the problem, the technical problem, the physical problem with the car. We have a competition which we need to outperform. We have different tracks which have very different requirements in terms of aero performance. But we have also the regulations, and one of our chief designers said once a very interesting stuff which I first didn't really understand when he said, it's innovation by regulation. And somehow that doesn't really work if you say innovation by regulation. But in fact, it's true because the FIA, our regulatory body, changes every year the rules to keep the car safe and to keep the show alive. In fact, the regulations drive innovation. And I give you again an example. The regulation forbids to use active suspension control. To have a very performant aero performance, you need to have a constant gap between the floor and the track. You would do this with an active height control, which you know from your cars. But as this obviously is forbidden by regulation, we mimic the whole system hydraulically. Yes, so again, the regulation itself was driving the innovation. And all of this leads then to all of this enormous amount of changes. And being able to do so, you really need to have processes in place which are robust, stable, and adhered to. If some people start to deviate out of this, especially on the update side, then you get into chaos. So we are very strict in terms of process adherence, but very flexible if it comes to changing them. And you can see we change software very often, we change process very often as well, but we are very, very strict in terms of adherence. For this, you need obviously very robust system in the background to do so. And that's where we found that putting stuff into the cloud helped us a lot. In fact, it was the enabler to do so. We don't want to be second, obviously, we want to be first. But we produce only 2 cars per year, as I told you, even though in 20 or 21 different configurations. If you try again to look at our industry, we are very similar than aerospace or defense. We use the same physics for the product. We use exactly the same materials. We use the same manufacturing technologies. But there's a very big difference in terms of timeline. So it takes 13, and I'm coming from aerospace. So it takes 13 years between inception of a new plane to roll it out into an airline. So as an engineer, you see more or less twice per your career a new plane if you are involved. We do this all in 12 months, and that's where the innovation really thrives, and that's where the leading edge of Formula One is really coming. It's about the speed of changing stuff. And with this, I would like to give you 2 advices which I found comparing my former life in aerospace and now in Formula One is you need to take advantage of data. I thought that data alone is not helpful at all. If you just produce data and store data, you don't gain anything. So the real key is making out of data information. And if you're then able to do out of information content, then you are a really big step ahead of everybody. And that's what we try to do. We try to make out of information content, something which at the moment only a human brain is able to do. Connecting points, making conscious decisions or connections. And that's where we try, and you were speaking about artificial intelligence, that's where we can see where it goes. Being able to get all this huge amount of data, all these different points and make correlations, connections, and that. So if you can make data into information, into content, you're a big step ahead of the competition. And the last one, and for me the most important, is with all this data and all this technology, it is the human beings, it's your employees who create the innovation. None of this is possible without the human beings. So what we see is you need to have a very motivated workforce. If people are able to connect to your product, are being proud of the product or the service, and working together as a team, you can achieve amazing things. And it's really the people working as a team using enablers like technology and IoT and whatever, which is available in the market, only then they deliver a very performant product and are able to get world champions. With this, I would like to finish. If somebody has any questions, I think we will have a short.
Let's hold those for the panel.
Okay, then.
Okay. So thank you very much.